Yep, I'm recording.
Cool. All right. Well, welcome everyone. So this was actually a presentation that I gave at a Python meetup that Banjo was actually at, and he happened to see it. And thought it would be good to present some of this material at the DataOps meetup. So I've actually slightly revised this content kind of for this meetup, but there is quite a bit of Python references throughout this. So just kind of keep that in mind as I go through the slides. So this is what we'll be going over. I'll talk a little bit about the data science lifecycle just at a high level, how we actually do data science at ZeroFOX, because that'll kind of pertain to a lot of the content I talked to throughout this presentation. Then I'll talk about some of the data science tools, what they focus on, like what we use in terms of Python. And then this is probably really pertinent to at least this group, is I'll talk a lot about our data set management and how we actually manage our data throughout its life cycle at ZeroFOX. And then I'll end it with a demo of Prodigy, which is a tool I've come to actually really love. And then we'll do a Q&A at the end. Since we have a decently small group, like feel free to interrupt me as I'm going through this. If you have any questions, I'll try to make sure I leave a little bit of time at the end of each slides, like just a bit of a pause. So if you do have any questions, just feel free to raise them then. So a little bit about ZeroFOX, since a lot of what I'm talking about like pertains to ZeroFOX, to give you a little bit of background, because anytime you're working with data, I think the use case really matters, because everyone's got a different use case. Everyone's dealing with different problems. So at ZeroFOX, we're a global cybersecurity company. Specifically, we deal with digital risk protection, which is focusing on protecting companies and individuals from security threats and any risks that are present on digital channels. So this can involve things such as social engineering, IP leakage, data loss, impersonators, scams, malicious domains, malicious emails, reputation-based attacks, and so on. So really a good way to think about what we do at ZeroFOX is that we're trying to protect companies from their public attack surface. So anything that can be public, we're really trying to help companies kind of understand and control. So at ZeroFOX, we hook into a number of digital channels. So there's obviously like the big ones that you're probably thinking of, like Facebook, Twitter, Amazon, Slack, and so on. But we also deal with domain registrars, websites, forums on the dark web, and email. So content will arrive within our system, and it's my team's job to surface that relevant information to customers so that they can then take some kind of action on it, whether that's a takedown or just being aware that, hey, this content's out there. We get tens of millions of unique pieces of content ingested every day from all of these different channels. And as you probably figured out, there's a wide variety and distribution of content. We'll get anything from text to images to audio to video to email. In order to make sense of this data and provide additional kind of context to our customers, we use artificial intelligence and machine learning, which Python really enables. And this is kind of what I'll be talking about today, as well as the data that we're working with and how we use it. So kind of moving on to the data science lifecycle. So this is the way I personally think about the data science lifecycle. And it's broken into these 10 distinct like stages or steps. And you start with really defining your problem and then collecting data, as well as creating labels, building a model, and doing your evaluation. And if everything goes well, then you can actually deploy the model so that you can actually use it within your production system. And what I try to illustrate here is that kind of the width of each stage in the lifecycle pyramid is a rough indicator of how much time you spend in each stage. While it's not like truly reflective of the amount of effort required for each stage. A good chunk of the work for any data science project really revolves around understanding your data, acquiring that data, cleaning it, and exploring it. So one of the keys to understanding this life cycle is that it's an iterative process and that each stage builds on the subsequent stage. So based on findings that we may get in the data exploration stage, that will inform us how we can actually build out our features, for example. And then as the project kind of moves down this pyramid, this flipped pyramid, the project should theoretically be growing in maturity and gets closest to an actual deliverable that you can release to address the original problem that you initially defined. And I'll say throughout this entire thing, we're using data to really inform our machine learning models and train them, obviously. So ideally, a lot of this has been enabled by Python, at least within our system. So moving on to data science at ZeroFOX, this is really how, at least within our domain, we view the world. So a lot of you are probably familiar with this, but I just wanted to clear up some definitions, is that AI is really the simulation of intelligent behavior within machines. And within artificial intelligence, there's a number of different techniques that you can use. One happens to be machine learning, which is where my team comes in. And this is really using algorithms and statistical models that can learn from all the data that you're collecting. And within machine learning, there's another technique called deep learning. And this is a way of using large neural networks, so neural networks with a lot of layers, to understand your data and discover these patterns that you're interested in. Specifically at ZeroFOX, we deal with two kind of niches within artificial intelligence. One is natural language processing, and this is a lot of what I'll be demoing today. And the other is computer vision, which is extracting essentially information out of the images or video. And I'll talk a little bit about computer vision too today, but we'll mostly be focusing on natural language processing, particularly in the demo I'll do later today. So this is a very high level architecture of how we do data science at ZeroFOX. I wanted to briefly introduce this because when I start talking about some of the tools and frameworks that we use, I'll go back and reference this architecture so you can kind of understand where it fits in within our life cycle. So on the production side, from the public internet, we're ingesting a ton of data. And from there, that flows into what we call enrichment. And this is where our machine learning and AI tools live. So that data will then get enriched with the information from our machine learning models. And then from there, we'll feed them into what we call the rule engine. And the rule engine is what determines what we alert on and what we don't alert on. And that alert then is surfaced to either our, like a ZeroFOX analyst or a customer. Once that information gets surfaced, what happens is then this flows back into what I really call our analysis system. So once an analysis or an analyst and a customer has taken action on the content flowing through our system, we'll actually take that back and we can use that then as a label. So I'll start back with this analysis section then. So in this case, we have analysts and customers essentially labeling this data for us. So when that happens, it starts to flow into our analysis system. And from there, we're able to take those essentially labeled data and then feed that into our training and validation and test sets. And this is what gives us a interesting feedback loop for our models, and that we're able to take this labeled data done by customers, take that, put that into a data set for our model, use that to retrain and test our models, and then update our models with that new training data and release that in production. So we have this feedback loop where content comes into the system, analyst, customer, human labels it, essentially flows back into our training set, and that helps us to further refine our models. So this feedback loop, and I'll talk a lot more about this later on, This feedback loop is really important to helping us keep our models, one, up to date, because machine learning models do decay over time, which is a critical thing to be aware of. And attacks change, especially in the cybersecurity realm. Attacks are constantly evolving. For example, with business email compromise, it used to be that they were just looking for replies via email, but business email compromise has really moved into the realm where they're trying to get you to call them or text them. So kind of moving that compromise, that attack offline, where it's harder to catch it. So now let's dive a little bit into data science tools. So this is definitely very Python focused, given the original presentation. So just keep that in mind. But again, like most of the tools that we use, at least for manipulating data and working with it, at least on the data science team here at ZeroFOX, are Python based. So what I tried to do is I tried to break these tools into 4 different categories. And while these tools can cross the borders of these categories that I've defined, just for the sake of simplicity, I've put them into one bucket. I'm not covering every single tool or framework that we use, but I'm really trying to bring attention to the tools that I think are important to be aware of, and that we really heavily use. So talking about these 4 buckets, one deals with data manipulation. And this is really, how do you structure your data and how do you perform transformations on it? Because most of the data you're going to get is not going to be something that you can just feed right into a machine learning model. You're going to have to, quote unquote, massage it in order to get that data into a format that a machine can actually understand. Data visualization is really about understanding what is the data that I'm actually working with. Like what potentially good features that I could use. How well is my model learning this data? How well are we actually capturing the patterns that is within the data? Modeling deals with teaching machines to really understand then those underlying patterns. So once you've kind of figured them out using data visualization tools, how do you actually create an algorithm to capture that pattern, or even understand patterns that you don't even see within the data? And then lastly, machine learning models are no good if you don't deploy them. So deployment is all about how do you integrate with whatever your platform is, and how do you make those models actually available to the customer so that they can either use them or at least benefit from the output of those models. So moving into data manipulation tools, really the big one here is NumPy. And at this point, I would almost argue that NumPy is inseparable from Python. It is really one of the key packages that gave rise to Python, more or less becoming the de facto machine learning framework. And what's really nice about NumPy is it allows you to represent matrices using data structures called an ND array. And beyond that, NumPy also includes a number of like mathematical and statistical functions that you can use to interact with these matrix and data structures that you have created. What's really interesting about NumPy is that behind the scenes, it's really driven by like C, C++, and Fortran. There's actually not a whole lot of true Python happening within NumPy. And a lot of times you'll hear the people talking about vectorized operations. Usually when they're talking about that, they're talking about using NumPy to speed up your code. So rather than writing maybe like a for loop to iterate over a matrix, instead you're going to use a vectorized operation that is enabled by a NumPy function. Pandas is another one that's really important to mention. Closely related to NumPy, but different. It's that really with pandas, the key structure is also matrix based, but you interact with this matrix through a wrapper called a data frame. What I find pandas really good at that NumPy maybe isn't quite as good at is dealing with time series data So whenever you're dealing with moving windows, like date shifting or so on, Pandas really excels at this, is what I found. And it can have, in my opinion, very fast operations, but it's a little bit less straightforward than NumPy, in my opinion, at least. Kind of switching gears a little bit, there is OpenCV. So OpenCV is a computer vision library, as well as a machine learning library, actually. And it is extremely useful if you're doing anything dealing with computer vision. I would, like, OpenCV is probably, again, the de facto computer vision library within Python. Its focus is performance, and because of that, there's a lot of use of OpenCV with real-time video, but it works just as well as on images. And it represents images as NumPy arrays that undergo various OpenCV operations that you do. And it provides most of what I would consider to be the basic building blocks for computer vision, but also has some really nice higher level operations as well, such as like huff transforms, or like hog detection, if you're into that kind of stuff. OpenCV is written in C++, but what's really nice is that it has interfaces for Python as well as a couple of other languages. It supports TensorFlow and PyTorch, and you can transfer model weights in between them.
Oh, wait.
What is surprising to most people, though, is that OpenCV, in terms of its image representation, it represents images as blue, green, red versus red, green, blue. And this is because OpenCV has been around for, I don't, like tens of years at this point. And at the beginning, when people were first working with images, there was a huge debate between, do you go with blue, green, red or red, green, blue? And OpenCV happened to choose blue, green, red versus RGB, which has kind of become the default these days. So if you ever are working with OpenCV, definitely be aware of that, and that the red and blue channels are flipped. And then another good thing to mention, also in the computer vision world, is Pillow. And this is, Pillow stands for the Python Imaging Library, or PIL. And Pillow is actually a continuation of PIL, which is actually deprecated now. And that confuses some people, because really Pillow is the default, but when you import it, it's PIL, and it gets a little bit confusing if you're working at it in Python. But all you really need to know is that PIL is the old version of what is now Pillow. For me, at least personally, I find Pillow to be really useful when you have basic operations that need to be done on the image. So if I don't have anything that involves in-depth like image transformations or analysis, like Pillow is pretty much always my go-to. Mainly because it has higher level operations than OpenCV. For example, it's extremely easy to create thumbnails using Pillow. It has just a function call that you have to do it, versus an OpenCV, you have to write that using the building blocks they give you. What I have found to be also interesting is that some of the modeling frameworks, such as like PyTorch or Keras, actually use Pillow behind the scenes. So if you've ever worked with like Keras's like image generator, or PyTorch's like Torch Vision transforms, they're actually using Pillow and not OpenCV. So these are where these frameworks kind of fit within our architecture, at least today. So in terms of our machine learning models, we're obviously using like NumPy, OpenCV, and Pillow. And then on the analysis side, we pretty much use all of these depending on the problem that we're working with. If it's a natural language machine, or like natural language processing problem, we're mainly using NumPy. If it is some kind of computer vision problem, then we're using OpenCV or Pillow.
Nobody was here. Nobody. Yep.
And then and then depending on that, or I should say, like in terms of actually analyzing our models, that is where for us at least Pandas comes in. We don't really use it much for any kind of training or any production model deploys, but we do use Pandas to analyze the performance of our models over time. Again, kind of a testament to Pandas' ability to deal with time series data. Moving on to data visualization tools. One of the heavyweights in here is Jupyter, which actually now is really Jupyter Lab. And what's really nice about Jupyter is that it is a essentially visual read, evaluate, print loop that runs in your browser, which is what makes Jupyter so powerful and why so many data scientists actually end up using it. Behind the scenes, Jupyter notebooks are actually just JSON documents that they interpret and then render actually within your browser. So Jupyter notebooks are run using something called kernels. And these are just processes that run that interactive code that you've written in a particular programming language. It doesn't have to be just Python. There's, I know, notebooks for Java or Julia or R or MATLAB even. And then these kernels then run that code and then return that output to the notebook, and that is what gets rendered. What's also really cool if you are a big GitHub user is that native rendering of notebooks, both like their code and their output, if you've saved your notebook, will actually get rendered in GitHub. Another interesting library, and definitely I would say like original, is matplotlib. And matplotlib is really nice because it's designed to work really well with NumPy. And it also supports a number of different GUI toolkits like GTK+, Qt, and so on. Out of the box, matplotlib will support 2D plots, and there are extensions if you need to do 3D plotting. However, matplotlib is a fairly old project at this point, and there are some newer ones now that I think are a little bit more powerful. One of those is actually Altair and Vega. And this is actually what we have been looking into recently at ZeroFOX. So what's really cool about this combination of Altair and Vega is that it's a declarative statistical visualization library. What that means is that you can essentially declare what your visualizations should look like, and then Vega interprets those and figures out how to render them. So Altair is the Python version of Vega. Vega, I believe, originally started off as a JavaScript project. So what we're actually looking at in ZeroFOX is, all right, so can we actually render the output of our models? For example, if it's a deep learning model running over an image, can we show the heat map to our customer? Like, what was the model actually detecting? Like, what was activating it? So we're looking at, all right, we can essentially render that visualization, turn it into JSON, send that to the front end, since it's just a JSON, and then render that within Vega on the front end. So that's why I think that combination is pretty powerful, and that's why we're looking at that at ZeroFOX today. There's another kind of big thing to mention, which is Plotly. And this is a cool tool because it is supported by a company. So if you do require like some kind of support for your like visualization framework, Plotly is probably a good one to go with. And it's a really nice framework for building data visualization apps, and it's very easy to work with. There are both open source and enterprise versions available. But what's really nice about Plotly compared to like Matplotlib or even Vega is that it creates very nice interactive charts. So if for some reason you need to drill down the chart or be able to slice and dice in certain ways, Plotly is like a really good way to go. And then this is just where these kind of data visualization libraries fit in our framework. They're all, at least right now, totally focused on the analysis side. And it's really about understanding our model, It's especially when we train it, like how well did we train it? Is it better than the previous version? Is it worse? Like where did we perhaps get better? Where did we get worse? Same thing in terms of our performance analysis. It's really important for us to understand like, hey, like this is what our model is producing. Like, is this actually helping customers? Is this producing, or is this producing like maybe too many false positives? Moving on to modeling tools. So spaCy is one of my favorites, and I'll be talking a lot more about spaCy in the demo I do. But what's really nice is that is a actual production-focused natural language processing framework. And they actually use a deep learning framework that they customized called Think to power it. And what's really nice about Think is they have optimized it for the CPU, which is really nice because most of you, if you're running machine learning models in production, most likely you're going to be running them on CPU, not GPU. Generally, GPUs are used just for training, and then CPUs are what you actually run your model on in production. I would definitely argue that spaCy is one of the fastest MLP frameworks out there today. But in order to get that performance, it doesn't have nearly as many features as some other frameworks out there. Some of you may be familiar with like the Natural Language Toolkit, NLTK. spaCy has less features in it, but it is also much faster. So there's a trade-off that you have there. What's also really nice is you can replace Think with like Keras or TensorFlow or PyTorch even. If you happen to already have like a natural language processing model developed and you just want to leverage some of the features that spaCy provides. What's also nice about spaCy is that it does provide some default models for you that are already like pre-trained, which is really nice if you want to do any kind of transfer learning and just have something to bootstrap a NLP model that you're starting to develop. The other thing I want to introduce, and this is really going to be the focus of my live demo, is Prodigy. And this is a really cool toolkit that was actually developed by the makers of spaCy that solves the labeling problem. The labeling problem, in my opinion, is one of the hardest problems to solve in the data science world. It enables active learning. And if you're not familiar with what active learning is, that is the idea that as you label samples, the model actually learns from those. So every time you label a sample, you run it through the model, you train the model on that single sample, and the model gets smarter as you go through with this labeling, which really gives you an idea like, hey, this is a model that's going to work down the line or it isn't. It also enables programmatic workflow definitions, which is critical in the data science world. I've been on both sides of this, so I can't tell you how many times I've taken a code from a data scientist that's just a mess of a Jupyter notebook and been told like, hey, we need to productionize this. On the other side, I've also been the data scientist, and I know I've handed over messy code to an engineer and been like, hey, this is what we need to implement, like have fun. So Prodigy helps to kind of eliminate that messy code and really force you to write your machine learning code and the data transformations and the other various things that you do in a very structured way, which makes it a lot easier to then take that code and actually turn it into a production project. I would definitely be amiss, I guess, if I didn't mention sklearn, because this is probably like the machine learning library that most people, when they first get started with machine learning, pick up. It has a good amount of support for pretty much every machine learning algorithm that you would be interested in. Kind of one of the downsides of sklearn though is it does not run on the GPU. So if you're trying to build any kind of like deep learning algorithm, you're going to turn to something else other than sklearn, like Keras or TensorFlow. What's also nice about sklearn is that there are a number of other kind of like sidekits available. One important one for us at ZeroFOX happens to be the scikit image project. And that's really useful for us because it deals with a lot of the more prominent, I should say, computer vision learning algorithms that are out there. And then back when I made this slide originally, Keras and TensorFlow were two separate projects, but for anyone who's kind of big into the deep learning world, you're probably aware that Keras and TensorFlow are now one thing, and that Keras now only supports TensorFlow. But what's really nice about Keras is that it gives you a programmatic way of defining models versus defining models in configuration files. And it used to be a set of abstractions on lower level backends. Now it's just abstraction on top of TensorFlow. And TensorFlow is more of the kind of low level mathematical framework that you're using mainly for deep learning tasks. So that's kind of the difference between the two. Keras is the high level and TensorFlow is the low level. What's really nice about both Keras and TensorFlow is they do support the GPU. So again, unlike scikit-learn, this is really where Keras and TensorFlow shine, is that if you do have deep neural networks, like Keras and TensorFlow are a great choice to build those models with. So again, just kind of relating this back to our architecture, one of the things I want to point out is where we're using Prodigy. So Prodigy is used all over our kind of like analysis stack. So anywhere where we're dealing with performance analysis, model training, development, labeling, we're using Prodigy. Depending on the model that we're developing, we may be using, Keras or TensorFlow, or spaCy or scikit-learn. It really just depends on the model that we're building. And then in terms of actual production, Keras and TensorFlow, spaCy, and scikit-learn, again, those frameworks are the main ones that we use here at ZeroFOX. And then last is deployment. So for us, we actually use Sanic to do most of our model deployments. And the reason that we do that is that Sanic is essentially a Flask-like framework, but focused on high performance. And secondarily, they're focused on ease of use. But that's really useful for us because most of our models we deploy as microservices with maybe 1 or 2 HTTP endpoints that you end up hitting on those microservices. So Sanic is really nice for that, in that it's extremely fast. We don't have to worry about, like a Bizig like server or running anything like that you'd have to worry about with Flask or Django. On the other hand, we do run at ZeroFOX Django. If you're not familiar with Django, it's one of the big like MVC web frameworks within Python. It's really focused on helping you develop like database-driven websites, which for us is critical because we obviously have an API that we expose to customers. And that's also how we generally interact with our database. So a lot of times, like sometimes our models will have to pull information from the database when we initialize them. So in order to do that, we're usually making calls out to our Django API. So these are much easier to kind of talk about in terms of where they sit in our architecture. Sanic, again, is what we wrap all of our machine learning models with. And then Django is what powers our API and what actually results in alerts getting created and database manipulations happening. Cool, so I'll pause here really quick. Before I move into dataset management, does anyone have any questions?
Do you use all those tools, or like how hard is it to learn how to use all those tools to connect them together?
Yeah, so we actually do use all of those tools. What's really nice is that a lot of them kind of just fit together naturally. For example, NumPy that I mentioned, like Keras and TensorFlow are using that. spaCy is using that. Like Prodigy uses that somewhat. So a lot of these tools are interconnected. Maybe the ones that are a little bit less connected are the visualization tools. That's really kind of a preference in what you need for your use case, versus anything else, in my opinion. Yeah, we do use all these tools. Learning curves vary, I would say, depending on your experience. I would say once you've picked up like a deep learning framework, maybe you have a lot of experience in PyTorch, it's usually pretty easy to then pick up like TensorFlow or Keras. Same thing with kind of like NumPys or Pandas. Like once you understand NumPy, it's usually pretty easy to pick up Pandas. But it really depends. I work with these tools every day, so just kind of like doing it over the course of, I don't know how many years at this point, a lot of years. It's gotten a lot easier to work with them and understand them. But what's really nice is like all the vast majority of the tools I mentioned, there's a lot of like really good documentation and tutorials online. So I think it's pretty easy to kind of like bootstrap your learning by just kind of going through that material and like kind of starting to write your own code. All right, well, I will move on to dataset management. So I mentioned this before, but labeling is probably one of the most important things that you have to think about when you're really trying to implement like a data science type architecture within your system. I mentioned this before, but you have to make sure that you're continually refreshing your models to maintain their accuracy. Especially in the cybersecurity realm, like attackers are constantly changing their attacks and adapting to what we're doing as defenders. So making sure our models like properly reflect that is critical. So one of the ways that we do that is we actually pull examples out of production and we have humans label them. Whether it's our like actual cybersecurity analysts that are labeling them, or whether it's us as a data science team going and labeling the data that we have coming through our system, we make sure humans are actually labeling this data. But what we do is that we make sure that this continually maintains a constantly growing training set for our model. And if what we've tried to do, what we've become now is much more diligent about making sure that we continually maintain our labeling pipeline. So we try to take like maybe a couple of hours each week to go through and label data to make sure that these data sets are continually growing. Because if we were not doing that, our models would get out of date. And then we'd be kind of in a rough spot if all of a sudden like we're like, hey, like the model, like our model accuracy has degraded by, you know, maybe 10%. We need to go through and retrain it, but we have no data to do the retraining with. So the way this works, the way this works at ZeroFOX is we have a model that's running in production. And that model is producing predictions, and those predictions, all of them will flow through our rule engine. But some of them, using just random subsampling, we will pull off and put into our labeling pipeline. For the predictions that are going through our rule engine, those will, some of those will end up being surfaced as alerts, which then our analysts will look at and take some kind of action on. Based on the action that the analyst took, that gives us a label. So that will also then flow into our labeling pipeline. And then also on the side, I just called this research, but any kind of investigation or additional data gathering that we're doing, that's kind of our research. And those examples will also flow into our labeling pipeline. So from there, we'll actually have humans, which is my data science team here at ZeroFOX. We'll actually go through and label this data. So once we produce that labeled data, we end up with some kind of data set that will end up splitting into, you know, train, validation, and test. We'll end up going through our model training. If there's a improvement in the model accuracy, we'll then push that updated model to production, and then that whole workflow will start over again. So that's how we, at least at ZeroFOX, have implemented our labeling pipeline. And this is a critical thing, I think, to making sure that we're staying in tune with the changing attacks that are happening every day. The other thing I wanted to mention was, how do we actually store these data sets? So we have followed kind of the data lake architecture, and a data lake is just a essentially repository of data stored in, I put it in quotes, it's raw form. What raw is depends on kind of like what stage you're at least within our life cycle. And what we do is we'll move transformations of the data into another data lake. So we'll ingest that raw data, as you see here, and then we'll label it. So then now we've got the raw data as well as it's labeled. And then we'll create features. So, you know, maybe we'll create feature set 1, and then we'll go and take a look at that data. Maybe that feature set wasn't exactly what we're looking at, so then we'll produce feature set 2. Maybe feature set 2 is something that we liked, so then we'll create 3 more data lakes where we split that now labeled features into training, validation, and test sets. And as you can see here, at least at ZeroFOX, we're using S3 as our backing data store for the data lake. And then we use Postgres to store essentially pointers to that data that resides in S3. So that's how we're able to kind of take this data from one data lake to another, do these transformations on it, and then keep track of not only where the data originally came from, but all the transformations that have been done. And this architecture, I think, is critical, because if you not keep around the raw data, it gets a lot harder to go back and then create new features off of it. So, you know, maybe for that feature set 1, we discovered that, hey, we're missing 2 critical features. If we didn't have that raw data stored, we wouldn't have been able to generate then feature set 2, which we ultimately ended up deciding to use to train our model. So this is one of, I think, the more critical slides in terms of understanding, like, how do you actually really work with and utilize data that you're trying to train a model with. If you do not keep that raw data around, like, you're going to be in a world of pain. You need to generate new features, and I have unfortunately been through that world of pain. So that kind of covers at least the slide portion of this presentation. Any questions before I move into the live demo? All right, awesome. So what I'm going to demo today is a tool called Prodigy that I mentioned. And Prodigy, again, is like what we're using to really manage our entire data science lifecycle. And Prodigy is, it was created by Explosion AI. And this is the same company that I mentioned before that developed also spaCy and Think. And their original kind of, I guess, use case for Prodigy was to make annotating data pretty simple, but it can do a lot more. Again, like, one of the biggest things that I think that it helps us do is it helps us create structured code within the data science team versus like a mess of a Jupyter notebook. One caveat though is this is a tool. It's actually a Python package that they give you that you purchase. Luckily for, I think, like the functionality that it gives you, it's fairly cheap. It's, I think, like around $400 for an individual license, and then $500 a seat for a team license. So it's pretty cheap given some of the cost of other tools within this space. We specifically chose Prodigy at ZeroFOX because it solved like the hardest problem that we were dealing with, which is how do you actually label data, and how do you manage the life cycle of the data as it flows through kind of your data science life cycle. Another really nice thing that was just a huge bonus is it has out-of-the-box support for spaCy, and it also supports computer vision annotation. Again, the 2 like big spaces that we deal within at ZeroFOX, which is NLP and computer vision. And then actually exports trained models as Python packages, so they're really easy to then import and just use within like some kind of wrapper that you can deploy out to production. So with that, let's go ahead and jump into this demo. I seem to have lost, there it is. All right, so can everyone see my terminal here? Is the text big enough?
3 terminals, yeah.
Cool. Just make this a tad bigger.
And if the meeting dies again, we'll just join it in 2 minutes.
All right.
Yeah.
So what I've done here is I've got a pretty simple setup. I've got a Docker Compose file here. In this Docker Compose file contains just essentially a database. So in this case, I'm just using Postgres. In the ZeroFOX world, we've actually implemented a custom database that Prodigy imports that kind of abstracts out the S3 portion that where our data actually lives, and then the pointers that actually live within Postgres. But just for the sake of this demonstration, we're just going to be using Postgres. The other thing to quickly mention here is that Prodigy also has this configuration file that you can define. And in this case, it's really simple. I'm just looking at the database settings. You can see I just use the defaults of Postgres here. And then I've got some additional stuff that isn't necessarily pertinent, but like labels, which will come in part when I talk about kind of the computer vision labeling that we're doing, as well as instructions for like an annotator that may come into this platform. So I'm just going to go ahead and start up this server. So just Docker Compose up. So we've got our Postgres server working. So now I'm just going to show you what's actually living within the database right now. So Docker Compose is at database, pSQL, and then our user is Postgres. And then apparently I can't type. Cool. So now we're within the Postgres database. So you can see there's no relations here. So with Prodigy, the way it works is that the first thing you're going to define is a data set. And the way you do that is there's just the Prodigy command that you call. And then you call what's called a recipe. In this case, the recipe is data set. So if I run the help information for this recipe, you're going to see kind of the information that this recipe takes. So it takes in a set ID.
All right. Oh, Matt, you're muted.
Oh, there you go.
Yep, there you go.
Sorry, so what I was saying is we're going to go ahead and call this dataset recipe. We'll call this dataset neg sentiment, because what I'm going to do is take you through like the full life cycle of training a negative sentiment classifier. And then just for description, we'll just say demo training dataset for negative sentiment classifier. And then we'll say I am the author. So this went and created that negative sentiment data set. And now if we actually go and look within the Postgres database, you'll see we now have some tables that are created. And again, this is just the default spaCy representation of kind of how your data lives. You're more than welcome to change this if you implement your own data set. or your own database, which is pretty easy to do. You just have to implement the interface that they've defined. That is a topic for maybe another meetup. So now if we look within our data set table, you'll see we have a data set created here. So here's the name of our data set, just when it was created. And then this kind of blob right here. This is just a base 64 encoded version of a JSON object. And within that JSON object is just the description and author of this data set. So the next thing I want to show you is what's called the stats recipe. And this stats recipe, we see here, has a number of different options. In this case, we can actually list our data sets if we do just L. So you can see here, we've got one data set, next sediment, which makes sense because I've only created one data set so far. But if we actually pass in the name of this data set, we'll get some more information. So in this case, you can see again the description and the author of the data set. And here, and this is what really matters to us, is how many examples do we have and how have they been annotated? Like how many of them have we accepted or rejected or ignored? And this will make a lot more sense once I start getting into the labeling piece. So with that, let's actually jump into the labeling piece. So what's really nice about Prodigy is that you can do active learning with it. And you can do that through this command called textcat.teach. And this is, again, a built-in command that's already available for Prodigy. And I probably should have mentioned this a little bit earlier, but all the recipes that I've shown so far are actually built-in recipes. There are also recipes that you can write, and I'll show you an example of those here in a minute. So textcat.teach, we take a look at what it takes. You can see there's a number of different options that we can provide here. So again, one of the main things being is the actual data set, so negative sentiment. And we're actually, you can see here that it takes a spaCy model. So this is where the transfer learning comes in. So there is a model that I know because I've worked with spaCy before called InCore WebSM, and that just stands for the small like English core language trained model. We're going to start with that as our bootstrap, and then since this is a negative sentiment classifier, let's just look for the word bad. And then I'm going to pull this information actually from GitHub. So Prodigy, again, has these idea of what are called loaders. And loaders are where you go to get your information. So in this case, we're going to go and get our information from GitHub issues, actually. And we'll assign the label to these of negative. Since either like the way we're going to train this negative sentiment classifier is that either text is negative or it's not. Keeping this like model as simple as possible. So if I go ahead and run this, you're going to see that, hey, it says, hey, go to your web server at localhost. So if we go to our localhost at 8080, this is where the Prodigy interface comes in. So right now it's pulling some GitHub issues that contain the text bad. So we'll see what this ends up pulling. Since this is a live demo, I'm not really certain what it's going to pull. But luckily this is GitHub, so it's usually nothing too bad. So entry for review says extraneous S-stroke. Like that's obviously not negative. That's also not negative. SSL error in Windows, also not negative. Artifacts in Go.3.2, not negative. Again, not negative. So we could probably go through this a bit, but in all actuality, like given that we are looking at GitHub, there's probably not going to be a whole lot of like negative sentiment on GitHub, as you can see here. So we'll just add a few more. And then we'll save these off. So you can see here that we've labeled 9 different examples of GitHub issues that we pulled. So I'm just gonna go ahead and kill this annotation server. You can see here that it said labeled or saved 9 annotations to the database Postgres. So if I run Prodigy stats neg sentiment now, you can see that we have 9 annotations and we rejected 9 of them. And reject does not mean like we're throwing out the example. What that means is that we said, hey, these are not negative. These examples do not contain negative sentiment. Within our database, if you look at the example table, you're actually going to see now we've got examples in here. And this looks like complete nonsense because, again, these are all base 64 encoded JSON blobs that are actually stored in the database. So not a whole lot to see there that's entertaining. The one piece that is entertaining is this link table. So if we look at the link table, what you're going to see here is we have example IDs and then dataset ID. So you can see that all of these examples have been associated with dataset ID of 1. And that, if we look at our dataset table, is our actual negative sentiment dataset. But then we have these 2 other things that were created. And these are what are known as sessions. So if you want to support, say, multiple people annotating the same sample, you can use these samples to support that. And then possibly you can do some kind of like analysis on the back end to decide like, hey, like maybe 3 out of 4 people labeled this text as negative. Let's actually consider this label to be negative. Versus like maybe you had 2 out of 4 people labeled as negative. Maybe you'll just throw that example out because you couldn't really determine what appropriate label was for it. So that's where samples are really useful, but at the end of the day, these sessions are always end up having those examples related back to the actual data set that you created. That's probably a lot of information I just gave you, but essentially what you really need to know is that sessions are actual annotation sessions. So when you go through and label, and then data sets are the actual, contain the list of all the examples that you've gone through and labeled. So now let's start getting to something that's a little bit more, at least in my opinion, interesting. So I wrote some code here. Make this a little bigger. So this is what an actual recipe can look like if you're working with Prodigy. So in this case, what I'm doing is I want to connect to Twitter, and they actually have a nice little Twitter loader already created for you. All you really have to do is set these various like keys in order to talk to the Twitter API. So in this case, I'm essentially just taking some default spaCy model, again, for transfer learning, some kind of the name of the data set that I want to associate this with, and then setting up my loader, which is going to pull tweets from Twitter. So that's what this negative sentiment textcat teach recipe does. So unlike the GitHub one that I showed you where their API is just open, this one's a little bit more locked down. So that's why you have to specify these keys, and that's why I wrote this recipe. But you can see it's pretty simple to define. Like once you look a little bit at the Prodigy documentation, this would all like make a lot of sense. But this piece right here is what actually defines that as a recipe and defines the arguments that go into that recipe. So if I were to show you this, you can see that those arguments that I defined in the recipe, they're showing up here within the text, or I guess the help screen that you'd look at for that recipe. We'll dive a little bit into this too later on, but I've also created this kind of evaluation data set. So once we've trained, or recipe, So once we train this model, we'll actually go through and pull examples again from Twitter and then compare like what the model thought to how we actually labeled them. And that gives us a really good idea of like, hey, this is how our model is actually working. So with that, let's go ahead and dive into actually pulling some tweets and labeling those. So we'll call, what was it? It was negative. I copied this or not. So Prodigy. And then again, our recipe. And then we're going to use that same negative sentiment data set. We'll put some more data into that. We'll bootstrap it with that same kind of default model that we have from spaCy. Again, we'll use the same text. We'll just search for bad. The label will be negative. I think, yeah, sorry, query. So I'm looking at my own help screen. And then I'll specify that Twitter recipe file. So a quick caveat, this is coming from Twitter, so hopefully there's nothing inappropriate on Twitter, but you know how that works. Cool, so this is our first tweet. They aren't that bad, all right, well, that's not really negative. That's not negative. All right, this is probably negative. We'll call this one negative. Not really negative. Probably negative. That's really sarcasm. We'll ignore that one.
Ignore it. Yeah,
that's a rough one. I don't even know who Dr. Drew is, but that looks negative.
Sounds bad.
This looks probably negative. We'll say that's negative. We'll ignore that one. Not really negative. We'll call that negative. Not negative. All right, well, I think we've got enough examples now, so we'll go ahead and save those. Then we'll kill the annotation server. So again, 15 more examples we just saved. So let's take a look at what our data set's looking like right now. So now you can see we've ignored 3 examples. We've now rejected 14 of them. We have accepted 7 of them. So what that means is that we have 7 examples we thought contained like some kind of negative sentiment, and then 14 that we didn't think contained negative sentiment. So this is actually what we're going to now train our model on. So to train your model, what's really nice about, again, Prodigy being by the same makers of spaCy is that they do have a built-in recipe to do model training. And that is this textcot batch train recipe. So you can see there's a lot of different options here because we are training a model, and there's obviously a lot of different kind of parameters you want to tune when you're training a model. But we'll keep this pretty simple. Again, we're going to use the negative sentiment data set that we've created now. And to bootstrap this, we're going to use this in-core web small model. Again, kind of leveraging transfer learning to hopefully like produce a model like sooner rather than later. We'll output this to a directory called train model. And then for our eval split, so how we're going to split this data set, we'll save off just 10% of the examples as our kind of validation data set, our evaluation data set. And then we'll train this for just 10 iterations. I should also mention that this is a deep learning model behind the scenes that we're training right now. So we're just going to train it for 10 iterations. We'll say, since we have very little data, we'll just say the batch size is 2. So this will kick off some training. And you can see this kind of flew through it. In reality, if you're working with any kind of like decently sized data set, trust me, it's not going to train this fast. And these are the results. So based on our kind of evaluation data set, which it looks like withheld just 2 examples, one that we accepted and one that we rejected, you can see the model got both of those right. So surprisingly, with like just 21 examples that we had, the model seemed like it learned at least something. And then just to show you, we now have this trained model directory here. So if we take a look within it, you can see here we've got a bunch of different information on the spaCy output that allows you to then take this model and actually use it in production. So let's just take a look at what this model has actually kind of learned. So we'll first input spaCy. And then the way that you load a model in spaCy is you just call spaCy.load. And then we'll pass it the directory where the model is actually stored at. So now we've got our kind of machine learning model that we trained loaded. So let us see what it thinks. So we'll pass it in a document here. We'll say, like, Matt is a bad person. Okay, so it thinks that that statement is negative, you know, with like a 61% confidence, which actually isn't bad considering we only had, you know, 21 examples that we started training with. Let's flip this word and just say Matt is a very good person. All right, well, apparently that is even more negative than me being a bad person. That's not really surprising though. I mean, just given that we only had 21 examples, like there wasn't a whole lot for this model to learn. It's interesting that it kind of flipped what I was expecting, but I mean, that is what happens when you don't have a whole lot of data. So the next thing I want to show you, we just exit out of that, is how we can actually create just like a quick evaluation data set and actually evaluate the model live and see what it thinks, which is a little bit better than this like little contrived example that I just ran. So we can do that using that recipe that I showed you before that I wrote, which is the native sentiment text cat eval recipe. In this case, and actually I need to create a data set for this because I want to store my evaluation data set separately from my actual kind of training data set that I used. So we'll call this negative sentiment eval. And we'll say demo eval data set for sentiment classifier. All right, so now we'll actually go ahead and take a look at how this model is actually doing on some tweets. So text cat eval, and then what do I call that? Negative sentiment eval. We'll use our trained model rather than that default model I've been using before, because we're interested in what the trained model thinks, not what the kind of default spaCy model thinks. And the same label that we used before, which is negative. The query this time will say horrible. We'll use that custom Twitter recipe that I wrote. All right, what did I What did I not type right here? Prodigy negative sentiment. Oh yeah, that's right. Was. All right, there we go. So let's take a look and run through a couple of tweets here. All right, that's probably negative. We'll ignore that one. I don't really know what to think about that. Nothing is sent away, produce. All right, that's not negative. Not negative. All right, that's probably negative. Not negative. Definitely negative. Definitely negative. 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 Definitely negative. All right, we'll save these off. So we ended up labeling 12 different samples. So let's take a look at how our model did compared to how we labeled. So the model did not do well. You can see here that it correctly identified 4 of those examples that we ran and incorrectly identified the other 7 of them. And in this case, you can see like our stats are pretty bad, actually ending up with a F-score and accuracy of just 36%. Definitely not great. But again, like for a model that we just trained over 21, examples, could be worse. Definitely could be better, but definitely could be worse as well. So hopefully that kind of gives you a pretty clear idea like how you can go through like an end-to-end data science lifecycle just using Prodigy and a lot of the built-in recipes. Really useful, especially if you're working in any kind of like natural language processing space. It's really easy to kind of like just bootstrap a small project, run a POC and get an idea of, like, am I headed in the right direction? Am I thinking about the right things? Do my features look correct? And so on. Really quick to start. So any questions before I jump into the computer vision side of it and just show like how Prodigy supports computer vision work?
Can the model, I guess, when it's labeled itself, can it try to like, I guess, update itself? Kind of like learn by itself, basically?
Yeah, so that's the idea behind active learning. Active learning is where every time you see a sample, at least if you have a label for it, you can feed that sample and that label through the model. It'll update itself after each example. So that's definitely the idea behind active learning, but you can't just, I guess, blindly give an example to a model without a label and expect it to learn something. That gets into the realm of like unsupervised learning, which is a very different kind of a workflow.
I don't know if this is when you want to talk about this, but thank you. This has been really helpful so far. We had looked at Prodigy a little bit at my company, and one thing that we were wondering about was scaling this to multiple annotators. I know there's a product called Prodigy Scale that was supposed to be coming out. Are you using that, or are you using something else? Or
yeah, that's actually a great question, because we have actually struggled with that at ZeroFOX. So there's a couple of ways you can address it just using Prodigy. I would definitely say we're actually also kind of like eagerly awaiting Prodigy Scale. But one of the ways you can work with it is, where's one of my labeling sessions? So if I launch this, if you see here, you see how this session says default?
Yeah.
What that is saying is like, hey, this is just the default session. It's just going to create a session and pull examples out of it. If you actually add just a simple query parameter called like demo, you'll see how that session changes the demo. That is actually how you can allow for multiple annotators. So each annotator can have their own session. Like I could have, like a session for Matt. I could have one for, like Banjo. And then we could each go and label all the samples that we have independently. And then on the back end, you can do some kind of like aggregation then to kind of correlate all the labels that each individual annotator did. So that right now is the support that you have for multiple annotators. And that's assuming though that you want each annotator to go and individually label each sample. What we decided to do at ZeroFOX, since we have the whole company actually kind of participates in labeling, we have actually just created one default session and kind of relied on our employees, given that we're using like employees, not like, you know, someone like something like Mechanical Turk, that, hey, they're actually putting like the time to actually create good labels versus just like going and just randomly drawing like maybe bounding boxes on an image or something like that. But yeah, it's through that session interface that you can have like multiple annotators labeling the same sample.
Great, thanks.
Cool. Any other questions? All right. So the last thing I just wanted to show really quick, I'm not going to go through the full life cycle again since you guys already saw that, but I at least wanted to show you kind of some of the support that Prodigy also has for computer vision. So in this case, I'm just going to create another data set really quick. I'll just call it weapons because that's one of the things that we're actually concerned with detecting at ZeroFOX. We'll just say demo for CV classifier. And then this is, again, another recipe that I wrote. And if you aren't familiar with it, Pixabay is a website that has a bunch of DRM-free images that you're allowed to use. So I wrote a really simple recipe just to talk to the Pixabay API and kind of load those into our system. So that's just what I'm calling now. So Pixabay image manual. Again, the data set will be weapons. In this case, since I'm looking for weapons, we'll just say gun is what I'm interested in. And then the Pixabay recipe that I wrote. So this will take us into this interface. And now you can see I'm pulling images from Pixabay that have some kind of association with the gun. So again, I can just go through and draw these bounding boxes. We'll say that's a gun. This is definitely not a gun. Not a gun. Again, here we have a gun. What's really nice is you can do these bounding boxes. If you don't like, if for whatever reason you don't want to work with bounding boxes, you can also do this kind of like labeling like this. So if I really wanted to highlight, hey, this is where the gun is, I could go through and do this. So just something like that. But just to give you guys kind of a rough idea of how it works for this kind of annotation as well. Then what's nice is you can flip between these different labels. So maybe because we're talking about weapons, like I'm interested in like labeling guns and knives. If we pretend this was a knife, I could label this as a knife. And maybe like, maybe this dog's face was like a gun, for example. So you can go and like label things like that. It's really, it's a really nice way of doing annotations on images at a pretty fast pace. I've definitely gone through in the course of a day, I can label about somewhere around 1,500 images in a day just by myself. And if the rest of the team's helping me, obviously we can get thousands of images labeled in just a single day, which really helps if you're trying to, produce machine learning models at a pretty fast clip. So with that really kind of ends my presentation. Just open it up for any kind of questions. And if anyone has questions that they want to ask me offline, here's my email address at the bottom. Feel free to go ahead and email me. Definitely happy to talk more about like Prodigy or any of the content I went over today.
I guess how many annotators are you guys actively have for some of your models?
Yep. So for everything other than email, because email is sensitive, so we have that limited to just a few employees. The whole company has access to do this labeling. And in particular, like if we're really in a crunch and we have this actually happened like, I don't know, maybe 2 or 3 months ago. We were in a huge crunch to get a machine learning model produced, and we had like 6,000 images. We asked the whole company to kind of like pitch in and help with labeling. And by the end of the day, we had 6,500 labeled images.
Oh.
So yeah, it's, I would say at that point, we probably had a little over 50 or 60 people that actually went in and did some labeling at some point. Again, though, we aren't having multiple people label each individual sample or each individual example. We were just, again, relying on like each example is shown once to one annotator. So if I actually needed, you know, like 60 people to label 6,500 images, that probably would have taken quite a bit.
Question, another person posted, can you annotate video?
That is a great question. The only way that you could do that through Prodigy would be if you broke the video down into frames and displayed each frame as an individual image. We actually do video analysis at ZeroFOX, and we don't use Prodigy for that kind of labeling.
Okay, well, thank you, Matt. Clap.
Oh, Matt.
All right. Well, thanks everyone, and a big thanks, you know, to 2.6 for putting this on, and Banjo for putting this all together.
Oh yeah, thank you guys for joining. I know nobody else has anything better to do, so. See, can you post this link to this deck?
Yeah, Banjo, I can definitely shoot you this link to this deck if you want to post it on like the meetup page.
Yeah, I
or...
can put it on the meetup page. That's fine.
Cool.